Okay, so we'll start our next topic, which is called association algorithm. Okay, now, of course, these are three popular ones: a priori, eclat, and FP growth. All this, but a priori is the base algorithm. Eclat and FB growth, they kind of build on a priori. Okay, so they take a priori forward basically. Okay,
Okay, sir.
so uh, so what is it all about? Okay, so here we are trying to find if two products are strongly associated or not. Okay, they are strongly associated or not. What does that mean, strongly associated? It means, does one factor impact another factor?
Yeah.
Okay, and mostly in the sales, and of course in the other things also we can look at. And the way it is designed is like, people doing A, are they also doing B? Okay, so the example that we have here is, we have a data set that we'll take here. We'll have the bills, right, of let's say retail store wants to know what kind of products people are preferring to buy together. Okay, so they will take out the bill and they will see which two products are strongly associated. That means, let's say everybody who buys onion and potato will also buy tomato, let's say, for example.
Okay.
Okay, so if people now in the bill, what they'll see onion, potato, tomato. If there's onion, they may not see tomato or potato. If there's potato, they may not see onion, tomato. But if there is onion and potato and you have tomato, that means these three, okay, people who buys onion and potato will go for tomatoes as well. And once you have, so once you have this knowledge, you can create a lot of things. You can create an offering. You can say, if you buy kg of onion, potato, and kg of tomatoes together, you get 20% off,
Okay.
right? Or you say that since any people are coming to buy tomatoes, right? If they buy onion and potato, you give discount on onion and potato. Okay, people will come and automatically you can charge twice the price on tomato. Okay, so so I mean, of course, it depends upon what you want to do, but
Yes.
our logic here, or our purpose here, is to just understand which products are strongly associated.
Okay.
So for that, okay, we need three variables, okay, or three factors. They are called as support, confidence, and lift. Okay, so support is for each individual items. Support is for each individual item. Confidence and lift is for association between two values, two different items. So support talks about how many transactions has product I. So if you take 100 bills, how many bills has, let's say, onion on it? Just onion. Okay, we don't worry about potato or tomatoes, anything else. So if you look at 100 customers coming to your store, how many of them buys onion? So if 20 people buys onion, we say zero point 0.2, right? 20% or 0.2 is the support.
Yeah.
Okay, so support talks about the popularity of an item that you are selling in your store. And now this is also important to know, because the products which have high support, forget about association, but even if you look at high support, people, has high support, uh, they would, they would, you would not want that to, what do you say, get out of stock,
Yeah.
right?
Yes, sir. Like
Right?
people will be consuming more. I mean, going.
Correct. Because that's your highest selling product, right?
Yeah.
So first thing is that you should be aware of your products which have high support. Okay. Second, we talk about is confidence. Confidence refers to likelihood that an item B is also bought if A is bought. So here, denominator is not the total bill, but the first product.
Yeah.
Okay. Okay. So let's say onion and tomato you want to find. Okay. If so you have 100 bills. Out of 100 bills, you have 20 onions. Okay. And then let's say out of those 20 onions, how many carries tomatoes? So tomato could be like 30 bills can have tomatoes. Okay. But among the onion, only 5 of them have tomatoes. So you don't take 30, you take only 5 because we're talking about conditional probability here. Okay. So more of a conditional probability. Okay. Confidence. So here we are looking at within those 20 bills which are in the onion, how many of them have tomatoes? So we call it as confidence of A to B. A is the denominator part.
Yeah.
Okay. With respect to onion, how much is the okay, uh, confidence of B? Okay. The lift talks about confidence by support. Okay. Confidence by support is your lift. Okay.
Yes, sir.
So these 3 things we need, and based on these 3 things, we can find which product is highly, um, you know, associated. Okay, so let's go here. Now I've got an example of 6 bills. Okay, I've got an example of 6 bills, and item one, which is milk, is in all the 6 bills. Two, sugar is also in the 6 bills, and coffee is in 3. Now, what is the support of milk?
6 support is 6 by 6, sir.
1, correct.
Yeah.
Okay. Support for sugar is also 6 by 6.
Yeah.
Okay. So, support and for coffee is
Half.
0.5.
Yeah.
Correct. So support for coffee is 0.5. So now you look, generally we start with one which has the highest support.
Okay.
Okay.
Yeah.
Now, okay, so this is good. Now I need to know the confidence of, okay. So here, okay, now we look at all the possible combinations. Okay, so if you see this algorithm may be simple, but the time that it takes to execute is very large because it is going to, you know, compare all the possible combinations. So here is going to compare milk to coffee, sugar to coffee, milk and sugar together to coffee.
Okay.
Okay, all the then coffee to milk, coffee to sugar, sugar and coffee to milk, right? Milk and coffee to sugar. All the possible combinations are captured. Okay.
Yeah. Yeah.
So if I have to find sugar to coffee confidence, what will be the confidence value?
Sugar to coffee.
Yes.
Uh,
So first denominator we will have support of sugar, which is 1.
one. Yes, sir. One. Yeah.
On top you have uh,
3.
confidence. Yes, confidence is number of transaction which has both by 1. So it is 0.5. I mean, 3/6 divided by 1. So it is going to be 0.5.
Okay.
Generally 0.5 is too high value. Okay.
Yes, sir. Yes.
You will not have, right? If you have 100 bills, probably 20 people will buy a particular product, and the
Yes.
25 people, right? So it will be a much lower value, but just to give you, for easy calculation,
Yeah.
we are using this. Okay. So once we have all this, okay, now since you have all these values, okay, so what we do is, okay, we don't go for confidence and lift first we look at the support. Okay.
Okay.
And we say that if support is more than 0.2 only, we are going to go further.
Okay.
Because we'll end up, I mean, if let's say out of 100, if only one person is buying one particular product, then it doesn't matter to see. If you are performing such analysis, okay, you might need just 3 or 4 or 5 values associated. Now you can get top 10 associated values, but you will not be performing or you will not be using all the top 10 immediately, isn't it?
Yeah.
So even the algorithm gives top 10 or top 15, but you don't have effort, you don't have time, and you don't have resources to take decision on all the 15 or 20.
Yeah.
So for you 5, 10 is enough. Out of 10, you might take action for 3 business decision basically. So I don't have to go and look for all the possible combination. I'll say, okay, find support for all the possible combinations, and then I'm interested in one with more than 20% only.
Okay.
So all the other combinations will be removed. Only one that meets your support. Okay, and then you find this association. Association is nothing but your lift. Okay,
Yeah. Yeah.
so that's what we do in this one. Okay,
Okay, sir.
and we can define your minimum support, minimum confidence, minimum lift value. Okay, so every time algorithm is running, it will remove those values which does not meet your requirement. If you do not give all these values, okay, it will perform all the possible combinations. Okay, it will perform, but it will be very, very slow, right? You don't want it to be slow, right? So it
Yeah.
is always, as we discussed, it is always your um, this ease versus accuracy. So instead of getting too much of accuracy, okay, just focus on what is right for the business. Speed, always speed matters.
Yes, yes, sir. Yes.
Okay, so let's try doing it. Okay, here we will be using a priori. Okay, a priori has all the data set, and we will use this. This is the location from where you can get the data.
Okay.
So let me go and get it. In fact, the other two which I told you, right? FB growth and ECLAC
Yes, sir.
has not been added to a priori. Okay, it's not been made standard yet. People are still developing, and I don't know. Maybe now they would have. People have developed. Okay, individual people have developed those algorithms, but it's still not been added to the standard
Data set.
not data set,
Library.
standard library. Yeah. Okay.
Okay.
So very simple. Let me first open the link. Okay. GitHub. So you have GitHub here, and market basket optimization. Okay, this is what we will take. So if you see, these are the bills. Okay, first person bought shrimp, almonds, avocado, vegetable mix, green grapes, whole wheat flour, yams, cottage cheese, etc. Second person bought only 3 items. Okay, third person bought only 1 item. Fourth person bought 2 items. Okay, fifth person bought is 5 items. Okay, so these are the bills. Okay,
Okay. Yes, sir.
okay. So let's read it first. So I'm going to say import pandas as PD, and I'm going to say from up here. Okay, I might have to install it. Okay, so let me comment it for now. Data equal to pd dot read csv. Okay. Okay. So now let me go here. Okay. Pip install. Okay. A P Y O R. Okay. Done. Now come here. Say from a Puri import. Okay. These things are not there. It only has your Puri algorithm. Okay. So yeah. So we have read the data. Now what we'll do is we'll put them as transaction as a list. Okay. And maybe okay, let's do that. So I'm going to create a list and I'm going to add each product to this list. Okay, so we'll go through for loop for I in range. Okay, for I in range, your len of data. Right?
Yes, sir.
Okay. Now it is going to go through each line. Okay, and I'm going to say here now your products dot append what? Append your product. Now okay, let
Data
me
you
do,
need to send.
yeah, so before that, okay, let me look at the size of I. Okay,
Okay.
so I'm going to say max equal to 0 and I'm going to say here for range. I don't know how many columns are there, right? So one option is you do the you know you it's in the data frame, right? So we can actually how do I get the size of this data? Print data dot
Shape.
shape, right?
Yes, sir.
So now let's run this and see. So it has maximum of 20 rows. No, columns. Rows we have 7,500, isn't it?
Yeah, yeah,
There are 7,500 bills that we have taken.
yeah.
Okay. And the product has a maximum of like the person who has bought maximum stuff is 20. So there are 20 columns, that is maximum.
Yeah.
So we have to go through. Okay, so I can say here in terms of max, okay, I can say goals equal to 20. I wanted to measure maximum values here, right?
Yes, sir.
So I'll get this here. Now, okay, now what? Now let's add products dot append. Okay, now I need to know each value, right? So I can say for I in range, and I can say for j in range 20,
Okay.
correct?
Yes, sir.
And now I will say append what? Append um, data of, okay, so data dot values, okay, row comma,
I, comma J.
okay, I comma j, right?
J.
Row
Yes, sir.
one, first row 1, then
Yeah,
column
yeah.
1 2 3 4, so on.
Yes.
Okay, and we'll convert this into string to add it as a string. So I'll say str of, okay. So now our data is ready. So if I print here products,
Sir,
yeah,
like already the names will be
it
strings
is in,
only.
no, yeah, it will be in string. Now see, the thing is, even if it is not there, we're converting into string.
Okay, okay.
Okay,
Okay, sir.
and yeah, so now from data frame we converted into list,
Yeah.
because this is what we will put input to the algorithm. Of course,
Okay.
there's too many values, so iterating through 20 into 7,500. Imagine, like iterating through a lakh, and
Yes,
then
sir.
values, then okay, performing append. Okay, so let it run. Meanwhile, we will call this association equal to a priori, and then you give all these values. So I will be giving all the products value, and then you give your own support. Okay, so minimum confidence, minimum support, minimum confidence, let's say 0.005, min confidence, okay, equal to, let's say, 0.5, okay, and min lift. So depending upon the output, you'll have to change these values again, right? Okay, done. Now, to find the result, okay, you want to print, okay, associated products are slash n, and I'm going to say here list of association. Okay,
What will be the output of this association, sir?
it'll tell you which products are associated. Okay,
Yeah, okay.
this for loop is taking a long time to run. We try to make some changes to this. If not, I'll put it in one way. Okay, so okay, here I comma j, okay, and okay, inside what is, I will delete this part. So what is j? So j is for j in, okay, range 20. Let's see if this will be faster than the, it is going to take time. Okay, so this is it. Okay, let it take its sweet time. If you have a more, um, you can try with a smaller data set to see the result faster. But yeah, that's how it does. Okay, and I told you there's another algorithm called eclat. Okay, now this takes a lot of time. See, that's the disadvantage of using a priori. Okay, it takes a lot of time. Okay,
Okay, sir.
So eclat and the FB growth is trying to make it
Okay,
faster,
reduce this time. Yeah, yeah, yeah.
reduce the
Okay.
time. Okay.
Okay.
So yeah. Okay. So if you look at eclat, okay, it's saying that something which does not have minimum support, we will not take into account only. Okay. So before that it takes, okay. It is easy to do that. Okay. Now eclat is not yet implemented in standard. Okay. If you want to see, you can go here and you can see the code.
Okay.
Okay. FP growth is interesting. Oops, I think I opened wrong file. Wait. Okay. So FP growth, okay, is another popular algorithm. I told you, right? The basic association, it uses a priori, but okay, it tries to make a priori's faster. That's the purpose of all the other algorithms. So what it does is, it creates frequency sets. Okay, so it creates frequency set, and let's say we have this as the bill. We have total 6. Okay, you have item 1, 2. Okay, milk, sugar, and you have item 3. Okay, so maximum items you have is 3. Okay, so 2 people are going for coffee, 1 for tea, 1 for bread. So this is how you create. The first step is to create frequency table. So we'll represent milk with M, S for sugar, T for tea, C for coffee, B for bread. So how many M milk is there? All the 6 bills have, so 6.
Yeah.
Sugar, 5, right? Out of 6,
Yeah.
1 is tea, so it is 5. Coffee, 2. Tea,
Two.
you have tea here and tea here, 2.
Yeah.
And bread is 1.
Yeah.
Okay. So here itself you are saying threshold equal to 2.
Okay.
Okay. That means anything less than 2, you will
Will be
not
eliminated.
include, eliminate it.
Yeah.
So before you find even support only, you are, you are removing this. So now you will end up with bread is out. You will not be using bread. Okay. Okay. So now we create what is called ordered frequent items. Ordered frequent items means when you create each of these bill, whatever is occurring maximum number of times will be on the left. Second will be the second maximum. So if you see here MSC, MTC, okay, MST, MSB, and then MSMS, right? And this fourth is remove. Bread is remove. Okay, so you get only MS here. So what you started here has become MSC, okay, milk, sugar, coffee, and milk, tea, coffee has become milk, coffee, and tea. Why? Coffee is appearing second time, right? So frequently appearing. So here, coffee has already appeared twice. So tea will be on the right hand side. Sugar and tea. Okay, here bread is out. We are not interested in bread. So you get MSMS. So the bill is not out. Item gets out. Okay, that means we will not be using bread to find association with anything else nor with
Yeah.
itself. Okay.
Yes, sir.
So start, take up threshold value, remove the values. Okay, and now you end up getting this. Okay.
Yes.
Now, okay, now we create a tree data structure. Tree.
Okay.
Tree, okay, same frequent items, we put it in a tree format. So here, first step, you start with MSC. So MSC you put. Okay. Then is MCT. C, okay, T is after C. Okay, so if I have to do it, wait. Okay, so first is anyway MSC, right? So you started here as root and you are saying M S C. So C M S. So okay, so we created this, and of course value of M is 1, S is also 1, and C is also 1. Now you take the second value, MCT. Okay, so you start from here, M, after M comes S, then comes C. Now in this case, okay, after M, C is coming. So you cannot go here because this, to go here, you have to go via S. So you will have another channel for C here. Now value for this C is also 1, but value for this M is 2, isn't it?
Yeah.
Okay,
Yes.
M, C, and then you have T here.
T. Yes.
So you go to next level here. Okay, you go for T here. MCT, then MST, MS. Okay, so we can follow this one, right? So you say M, S, and then we go and create here T. You can't come here because this has a different route, right?
Yes, sir.
So you get MST. Now, generally what we do is we put, these at the same level. Okay. So, okay. So if T is here at level 4, you will come down to level 4 here and say you put T. So this T is also 1. This T is also 1. This has become, this was third, right? So yes, M, S, T. Okay. Next is MS, MS, MS. MS, MS, right? So M, S, M, S, with M, S, right? So this is your final value. Okay. So this M is appearing how many times?
Mm. All the 6 times.
5, 6 times,
Yes.
right? M is appearing 6 times.
Yeah.
MS is appearing how many times?
So 5.
Yes, MS is appearing 5 times.
Yeah.
MSC is appearing how many times?
1 time.
Yes. And MC is appearing how many times?
MC.
Yes.
1
Okay.
time.
So we create conditional pattern.
Okay.
Okay. Conditional pattern. Okay. Will start with the products that you have. So you have M. Okay. Generally we start from bottom, minimum number. So you have T, you have C, you have S, and you have M. Right? So M with M, right? M, okay. M is maximum. So M doesn't make sense that M will go to anything else.
Yeah.
Now T goes with MC and MS,
MS.
right? So you say MS 1, MC
1.
1. Similarly, C. C is what? MS. Okay. MS1 and
Actually,
M1.
M also. Yeah.
So MS1 and M1. Okay.
Yeah.
Then S.
M. M.
M, right? S is the only way. And 5 times.
Oh, yes, a 5. Yes.
Okay. So let's see here. You do all these things. Finally, you end up getting this. Okay.
Yes, sir.
Now we look at the values which is occurring maximum number of times. Here M is occurring 2. Okay. And S is occurring 1, C is occurring 1. So let's say we drop 1. We only look at values which are occurring 2. Okay. So here also M is occurring twice. Here also M is occurring 5 times. So what we need to, okay, so before you actually perform any operation, we came up with this. So now you see T is mostly goes with M, C also mostly goes with M, S also mostly goes with M, right?
Yeah.
So you find the association of milk to sugar, milk to coffee, and milk to tea. That's
Okay.
it. You don't have to find milk and sugar to tea, milk and sugar to coffee, milk and tea to sugar, milk and coffee to sugar. All those things is not required. Okay.
Yes.
Now you have reduced the problem to a very simple problem. Right? Now you perform same a priori, but now we are only looking at M because this is what is appearing maximum number of times with each of these. Okay. You don't have to compare M because M is maximum, so anything will go with M. So
Yes.
TCS is what we're going to compare with M. So okay, and then you run it. Okay, I think there's a here. Okay, again, this fellow has developed algorithm. You can actually see the code. Okay,
Yes, sir.
that is it.
Okay, sir. So out of these three, first one takes more time.
Yes.
Okay, sir. A priori.
Okay, so see, it gave none here because probably this was too big.
Yeah.
Okay, there is no data set which could meet these minimum values.
Okay.
Okay, so we can end it here for today. Okay,
Okay, sir.
tomorrow we'll talk about time series.
Okay.
Okay.